mix it. Let's match it. Here we go. C to the negative second times c to the seventh. We add the exponents. Negative 2 plus 7 is 5. C to the fifth. 3r, which is 3r to the first, times r to the fourth. Remember, we can add the exponents of the like bases. So that would be r to the fifth. And then the 3 just kind of hangs out in front. 3r to the fifth. Now, when we do have those numbers in front, we can always multiply them. 5 times 2 is 10. Because if we're going to add the exponents, they have to be the exact same base, which these are not. So we just multiply. Now these t's are the same. Negative 2 plus negative 5 would be negative 7. Make your adjustments. Now 10 is 10 to the first. That doesn't have a negative exponent, so that stays. Only thing moving is the t to the seventh goes to the denominator. Guys, be careful. I told you to be careful. These are scary. Woo! Whoa, it's scary how many problems I put on here. My goodness. All right, the x's, I have 5 plus negative 6. That gives us negative 1. The y's, I have 2 plus 1. That's 3. X staying or moving? Moving. Is the y staying or moving? Staying. So the y to the third stays up top. The x to the first moves to the denominator. Cool. Number 17. Now we do have some similar bases here with 3 and 3. And sure, you can make that 3 to the second power, but we're looking for a number out in front, so we could just go ahead and multiply it. 3 times 3 is 9, times 5 is 45. Now we have x's, we have x to the fifth, times x to the second. 5 plus 2 would be 7. And then we have the y to the sixth. You don't have any negative exponents or zero exponents, so that would be our final answer. Okay, our numbers out in front, 4 times 3, that's a 12er. For the a's, we have a to the first times a to the fifth. 5 plus 1 would be 6. And then for the c's, we have 4 plus 3 would be 7, plus 1, don't forget about that one, would be to the 8th power.